So this is another shorter note just because we are still reviewing grade 10 concepts. So one important thing that you're going to have to know in grade 11 and grade 12 chemistry is balancing chemical equations. So you did learn this in grade 10. Some of you, I'm sure, are really great at it. Some of you might have struggled with it, and that's okay. But it is something that's going to come back, not just in this unit, but the next unit and the unit after that. So it is pretty important that you have an understanding. So we're going to take a little bit of time today and we're just going to hopefully remind you how to balance chemical equations. So from the last note, we said that a chemical equation is this shorthand way of representing a chemical reaction. So it uses those actual chemical formulas to take a look at what's happening in a chemical reaction. There are both reactants and there are products in this chemical reaction. So reactants is anything that goes in, and products is anything that goes out. And this little arrow here we mentioned in the last note is a yield sign. So that just pretty much means that the reactants are going to form the products. Now, before we get into what balancing is, we want to talk a little bit about why we balance. So an important concept of why we balance is called the law of conservation of mass. So essentially what the law of conservation of mass states is it says that a reaction is equal to the mass, or reactants are equal to the mass of the products in a chemical reaction. So essentially what that means is how many reactants go in, that's how many products have to come out. It pretty much means that matter cannot be created or destroyed. So we're not going to see mass increase or decrease in this case. The mass of all of the reactants have to equal the mass of all of the products. In any chemical reaction, what happens is the atoms are simply rearranged. So we're not changing the number of atoms, we're just changing what they're bonded to. So for example, in this case, our reactants, we have potassium, we have chlorine, and we have oxygen. And for our products, we have potassium, we have chlorine, and we have oxygen. So all that's happened is our atoms have actually just gone through and they've rearranged themselves. So since the law of conservation of mass is always in play, that means that we have to have equal numbers of potassium on both sides, we have to have equal number of chlorines on both sides, and we have to have equal numbers of oxygen on both sides. Sometimes that happens when we write it, sometimes it doesn't. You can see that on the left-hand side, I have 1 potassium, I have 1 chlorine, I have 3 oxygens, whereas on the right-hand side, I have 1 potassium, I have 1 chlorine, and I only have 2 oxygens. So if that happens, we use what's called stoichiometric coefficients to balance. So all that a stoichiometric coefficient is it's a big number that we go ahead and we place in front of a compound or an element. So that big number that we place in front of a compound or an element is going to multiply out. So it's important to remember that it has to be a big number, it can't be a little number, and it has to go in front, it can't go behind. So we're going to take a look at an example of what I mean by stoichiometric coefficients. You can see that we've added a 2, we've added a 2, and we've added a 3. They're big numbers, and what that does is it actually causes this reaction to be balanced. So if we were going to go ahead and we were going to count potassiums on this side, right? So I'm going to count potassiums on the left-hand side. Got to be able to write first. Nope. Let's try to go down. That's better. So I'm going to count potassiums on the left-hand side. You can see that there's a big 2 in front of the K. So what that means is I have 2 potassiums on the left-hand side. On the right-hand side, same idea. I have a big 2 in front of that K. So what that means is I have 2 potassiums on the right-hand side. Let's go back to the left-hand side and see how many chlorines I have. There's a big 2 in front. Since there's a big 2 in front, that multiplies out for chlorine as well too. That means I have 2 chlorines. Over here on the right-hand side, on the product side, again, there's a big 2 in front of chlorine. So that means that's going to go ahead, that's going to multiply out. I'm going to have 2 chlorines as well too. For oxygen on the left-hand side, let's take a look at oxygen. We have a 2, but we also have this little 3. that little 3 is going to be multiplied by the 2. So 2 times 3 is going to be 6. Oxygen on this side, we have a 3 in front, but we also have this little 2 here. That 3 and 2 are going to go ahead and multiply out. So that means I'm going to have 6 oxygens on this side here. So you can see that by using our stoichiometric coefficients, we're just going to go ahead and we are going to adjust them, and we're going to make it so we have equal numbers of atoms on the left-hand side, and so that we have equal numbers of atoms on the right-hand side. So for balancing, we actually call balancing by inspection. So essentially what you're going to do is you are going to add your stoichiometric coefficients, and you are just going to keep adding them and keep changing them until you find that your left-hand side matches your right-hand side. So that's kind of the tricky part with balancing that a lot of students struggle with, is there's no necessary right or wrong way to start balancing. There's no magic way that you're going to start with balancing. There's some skills you're going to pick up along the way for sure. That just comes with practice. But I could maybe start with one element, you could start with another element, and we're still going to both come to the right answer. So I'm going to show you how to balance. The first one that we are going to look at balancing, let's take a look at a bit of an easier one first. We're going to take a look at this one here. So what I'm going to do is I'm just going to scroll over. I'm going to give myself lots of space, and I'm going to write this out again. And we're going to remind ourselves how we're actually going to count these atoms as well too. So I'm going to record this reaction up top here. I'm going to leave out the states for now. We know that in a proper chemical reaction, I would have the states in there. I just want to give myself a little bit of space since this is kind of our first reminder of balancing. So the first thing that you want to do is you want to list what you have on the left-hand side on your reactant side and what you have on the right-hand side on your product side. So on your reactant side, we see zinc as an element, we see hydrogen, and we see chlorine. On the right-hand side, we also see zinc, hydrogen, and chlorine. So now one tip for balancing, you don't always have to follow this, but one tip is I always try to list my elements in the same order. So notice that zinc, hydrogen, and chlorine are listed in the same order on the left and on the right. That just makes checking back and forth to make sure you have the same number a little bit easier. Now what I'm going to do is I'm going to count what I have on the left-hand side. So with zinc, I don't see any coefficients in front of it. That means I have 1. For hydrogen, I don't see any coefficients. I have 1. And for chlorine, same idea. I have 1. On the other side, for zinc, I only have 1. Now careful, because hydrogen is listed next, but hydrogen isn't until the other side, and hydrogen isn't until the end. Hydrogen's over here. So we're going to take a look at hydrogen, and we see that little tiny 2 right beside hydrogen. That means that I have 2 hydrogen atoms. And for chlorine, I see this little 2 here, so that means I have 2 chlorine atoms. So my next thing to ask is, am I equal? If I take a look at my left-hand side and my right-hand side, we see that I'm not equal. So my next question is, what is not equal? Well, if we take a look at our hydrogen and our chlorine, we have more hydrogen and chlorine on the right than we do on the left. So we want to go ahead and we want to fix that. In order to get the correct amount of hydrogen and chlorine, we're going to have to increase the amount of hydrogen and chlorine on the left. So here I can see I have 2 hydrogens and 2 chlorines. So I'm just going to go ahead. I'm going to try to put a 2 in front of here, and I'm going to see what happens. So what that means is if I put a 2 in front of here, I now have 2 hydrogens, and I now have 2 chlorines. Now I'm going to inspect and see if my numbers match. On the left, I have 1 zinc. On the right, I have 1 zinc. I'm good. On the left, I have 2 hydrogens. On the right, I have 2 hydrogens. I'm good. On the left, 2 chlorines. On the right, 2 chlorines. I'm good. I'm balanced. By adding simply 1 coefficient in front of hydrochloric acid, I was able to balance this chemical equation. So that's it. That's balancing by inspection. There's really nothing else that I can teach you. Again, there's just little tips and tricks that you're going to pick up along the way. That was quite an easy one to balance. So what we want to do now is we want to try a little bit of a more challenging one. We are going to try to balance this double displacement reaction here. So what I recommend, balancing is really important to practice, practice, practice. So I recommend pausing the video and seeing if you can actually figure out how to balance this on your own. I'm going to go ahead, I'm going to give myself more space. So I'm going to rewrite my chemical equation. And I want you to come back once you've at least attempted this on your own, following the same steps, and see what you came up with. So all I've done is I've copied out my chemical reaction just as I saw it, and I'm going to go ahead and count what's on the left and what's on the right. So on the left, I have nitrogen, I have hydrogen, I have oxygen, I have potassium, and I have phosphorus. So I can see nitrogen, hydrogen, oxygen, potassium, and phosphorus. Now the tricky part is you can see a couple of these elements are in different spots. So nitrogen is only in one spot. I only have one of it. Hydrogen is only in one spot. I have 4 of them because there's that little 4 right beside hydrogen here. Nitrogen, oh look, I actually have it in 2 spots. So I actually have nitrogen here, I have nitrogen here, so I actually would have 2 nitrogens in this case. Oxygen, I have an oxygen here, and I also have oxygen here. So you would want to go ahead and add these together. So I have 3 and 4. That means I'm going to have 7 oxygens. Now for potassium, I only have potassium in one spot. There's a 3, so there's 3 of them. And for phosphorus, same idea. I only have phosphorus in one spot, so I only have 1 of them. I'm going to go ahead now and I am going to see how many I have on the right-hand side. So I'm going to write out my elements in the exact same order just because it makes it easier to compare back and forth. So I'm going to take a look at nitrogen first. If you take a look at nitrogen, I have it in 2 different spots. So I have it here, I have 1 here, but I also have nitrogen over here. Now what I want to point out is this bracket. So you can see that there's a bracket around NH4 and there's a 3 outside of the bracket. You learned in grade 10 that anything that is outside the bracket is going to multiply out. So I have 1 nitrogen inside the bracket, I have a 3 outside of the bracket. That means I'm going to have 3 nitrogens in this compound here. So I have 1 nitrogen and 3 nitrogens. That's going to give me a total of 4 nitrogens on my product on my right-hand side. Now let's take a look at hydrogen. I only have hydrogen in one spot here, and it is again with this bracket. So inside the bracket, I have 4 hydrogens. Outside the bracket, I have 3 hydrogens. So total, I'm going to have a total of 12 hydrogens. For oxygen, I have oxygen in 2 spots. I have oxygen over here with a 3, and I have oxygen over, I have oxygen over here with a 4. So I need to add these 2 numbers together. I'm going to have 7 oxygens on this side. For potassium, oh no. I erased this too, didn't I? I had 4 of these, yeah. For potassium, I only have potassium in one spot, and there is only 1 of them. And for phosphorus, same idea. I only have it in one spot. There is only 1 of them. So my next step, this seems overwhelming because it seems more challenging, but my next step is going to be the same. I'm going to compare what I have on the left, what I have on the right, and I'm going to see if it's equal. So on the left, I have 2 nitrogens and 4 nitrogens. So already I'm not equal here. I need to increase my number of nitrogens on the left-hand side. I have 4 hydrogens and 12 hydrogens, so I'm not equal for hydrogen either. My oxygens right now are good. My potassiums are not equal. I have to increase potassium on this side. And my phosphoruses are equal, so we're good for phosphorus. So now here's where it's actually going to vary. You can actually pick to start trying to fix nitrogen. You can try to fix hydrogen. You can try to fix potassium because all of them aren't equal. So this is where balancing gets a little bit different. You have a little bit more creative control. I'm going to try to fix potassium first. The reason I'm going to pick potassium is because potassium is only in one spot on either side. So since it's only in one spot, it's going to be easier for me to fix. So for potassium, I can see that I have 3 on the left and I only have 1 on the right. That means I want to have 3 on the right. So I'm going to go ahead, I'm going to put a 3 in front of this potassium. So that means I'm now going to have 3 potassiums. But by doing so, I've also changed my number of nitrogens, and I've also changed my number of oxygens. So we have to go back and we have to recount nitrogen, and we have to recount oxygen. So let's look at nitrogen first. I now have 3 times 1. That's going to be 3 nitrogens here. And remember, I had 3 nitrogens over here. So now I actually have a total of 6 nitrogens on the right-hand side. When I changed my oxygens, I now have 3 times 3, that's going to be 9. And over here, I have 1 oxygen, so that's going to be a total, oh no, sorry, I lied to you. I have 4 oxygens, so that's going to be a total of 13 oxygens over here on this side. So I've now got 6 nitrogens, I've got 12, is that right? I have 12, yes, I have 12 hydrogens, I have 13 oxygens, 3 potassiums, and I have 1 phosphorus. So we've fixed our phosphorus, but our nitrogens, our hydrogens are still not equal, and now our oxygen is also not equal. So we want to look at fixing those. So my next thing I'm going to try to do is I'm going to try to fix my nitrogen. So I have to get a little bit tricky, and I'm going to see how I'm going to fix my nitrogen. If you can see, nitrogen and hydrogen are actually together. So by fixing my nitrogen, I can also fix my hydrogen. So on this side, I have 4 hydrogens. On this side, I have 12 hydrogens. So in order to get 4 to equal 12, what number do I want to multiply 4 by to give me 12? Well, that's going to be 3. So when I put a 3 in front of there, I've now changed it. I now have 12 hydrogens. My hydrogens are now equal. But I didn't just change my hydrogens, I also changed my nitrogens and my oxygens. So I'm going to check and I'm going to see how I change this. So here I have 3, 3, and 3. That means I'm going to have a total of 6 nitrogens in this compound. And for oxygen, I now have 3 times 3 is 9. Plus over here, I have 4. So that's going to be a total of 13 oxygens. I'm now going to stop. I'm going to balance by inspection, and I'm going to see if I have the correct numbers. So nitrogen on the left is 6. Nitrogen on the right is 6. They match. We're good. Hydrogen on the left is 12. Hydrogen on the right is 12. They match. I'm good. Oxygen 13, 13. They match. I'm good. Potassium 3 and 3. Phosphorus 1 and 1. We have now balanced by inspection. So hopefully you're realizing that don't get frustrated with balancing. You're going to make one change. It's going to change everything, but it might be the change that's getting you towards the right step. So balancing is just kind of going back and forth. You might have to constantly make changes. Stick with it, I promise. And the other piece of advice that I can give you is always balance with a pencil because you're probably going to have to make lots of changes. So the last thing I want to do is I want to really challenge you. So combustion reactions are actually always the most challenging to balance. So I want you to go ahead and I want you to try to balance this combustion reaction here. Again, try it on your own. Pause the video. See if you can actually do this on your own. If you can balance a combustion reaction, I guarantee you, you can balance anything. While you're working on that, I'm going to go ahead and I'm just going to copy out my, my formula here. I'm going to give myself some more space. So we're balancing butane, oxygen, carbon dioxide, H2O. Now notice that there is an E over here. You're going to learn more about that E as we talk about this unit. That E just means energy. You actually don't have to balance energy. There's going to be a whole unit on energy going in and energy going out of a reaction. That's going to be grade 12 chemistry. So anytime you see this E, well, it's important for the chemical reaction. We actually don't have to worry about balancing it. We'll worry about that in grade 12. All right, now that we have everything written down, we're going to go ahead and we are going to record what we have. So on the left-hand side, I have carbon, I have hydrogen, and I have oxygen. And over here, I have carbon, I have hydrogen, and I have oxygen. And you're thinking, how can combustion reactions be that hard? It is only 3 different atoms, and they're always the same type of atoms. So let's count how many we have. I have 4 carbons on this side, and I only have 1 carbon on this side. On this side, I have 10 hydrogens, and on this side, I only have 2 hydrogens. On this side, I have 2 oxygens, and on this side, I have 3 oxygens. I have 2 here, and I have 1 here, so that's going to be your total of 3. Now we're going to go ahead and we're going to check. Carbons are not balanced. I have 4 on one side and 1 on the other, so I'm going to have to add carbon to this side. Hydrogens are not balanced. I have 10 on one side and I have 2 on the other, so I'm going to have to add hydrogen to this side. And oxygens are already not balanced. I have 2 on one side, I have 3 on the other, so I have to add oxygen to this side here. So we can start wherever we want. I recommend for combustion reactions starting with carbon. That's probably your easiest spot to start. So I have 4 on the left. I'm going to go ahead, I'm going to try to put a 4 in front of here, and I'm going to see if this is going to balance. So I've got a 4 now, so my carbons are now good. Now I have oxygen. That's changed my number of oxygens as well too. So I actually have 8 oxygens over here. I only have 1 oxygen over here. So that is going to make a total of 9 oxygens. Now, this is where combustion reactions actually start to get tricky. And there's something that I want to point out to you. The only oxygen you have on the left-hand side is 2. On the left-hand side, you can only have even numbers for oxygen, right? You can't multiply this by a fraction, not yet anyways. We're not able to multiply that by a fraction or a decimal. So we always have to have an even number of oxygens. But I want to point out to you that over here, oxygen is actually an odd number. Since oxygen is an odd number over here, we only have 1, that means that we're always going to have an odd number of oxygens on the right, and we are going to have an even number of oxygens on the left. Tricky. So how do you fix that? The easiest way to fix that, the fact that we have odd on one side and we have even on the other side, is to go ahead and put a 2 in front of here. We're going to try to put a 2 in front of here, and we're going to see if that's going to even out our odds and our evens. So now if I put a 2 in front of here, this is going to change my number of carbons. I'm going to have 8 carbons, and I'm going to have 20 hydrogens. That means I need to change my number of carbons again on my right-hand side. So I now want to have 8 carbons, so I'm going to change this 4 to an 8. That is going to mean that I have 8 carbons. For my number of oxygens, I'm now going to have 16 over here. And I still only have 1 over here for now. So that's going to mean that I have a number of 17 oxygens over here, right? So it seems like we're in the same predicament. But let's take a look and let's see our hydrogens. So for hydrogen, I now have 20 hydrogens. So over here, I now want to multiply this by 10. Before it was 5. I only had 10 hydrogens before. I want to multiply by 5. Now I have 20 hydrogens since I've doubled. I now have 20 hydrogens. That means I need to multiply by 10. So I've got 20 hydrogens, but when I multiply by 10, this now means that I have 10 oxygens. So I have 10 oxygens in water. I have 16 oxygens from carbon dioxide. That means I'm going to have a total of 26 oxygens. So carbon is equal, hydrogen is equal. The only thing that's not equal right now is my oxygens. I have 26 on the right-hand side. So what do I want to multiply 2 by to give me 26? I want to multiply by 13. If I multiply by 13, that's going to give me 26 oxygens on this side. So let's double check. Carbons are equal, I'm good. Hydrogens are equal, I'm good. Oxygens are equal, I'm good. Notice you have a really ugly number in front of your oxygen. That is pretty standard for combustion reactions. So if you ever get stuck in a combustion reaction and you're not sure what to do, try doubling this number in front here. That normally works. The other thing that you want to check for right now is sometimes when you're balancing, you might double something by accident. So you need to make sure the coefficients are in their lowest common form. You want to make sure there's no lowest common denominator. So essentially, we're going to make sure that there's no number that can divide into all of these. Well, there's no number that I can think about that can evenly go into 2, 8, 10, and 13. This is the lowest common form, so therefore, this would be the way that we balance this reaction. That is it. That is balancing. That's all I can teach for balancing. You now need to practice, 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 practice. The key for balancing is practicing lots. That's how you're going to get those instincts and figure out how to add what to each side. So there's a big practice worksheet that I did there. Please make sure that you do it because there is going to be an assignment on balancing as well too. So we are now totally caught up with grade 10 concepts. We're ready to start talking about those types of reactions in more detail. So in the next lesson, we are going to revisit synthesis reactions with a grade 11 spin. Have a great day, and we will see you guys later.